All right, guys. So here we are finishing off the end of this chapter with angles of elevation and depression. So it's a bit more problem solving, application based, and working out scenarios. So how you're going to, I guess, bring up the triangle, generate the triangle that is applicable to the story. So what we have here, just thinking that you're at the bottom, your friend's on top of a building or somewhere, and what we have here is, I guess, the line that is direct from you to your friend. Now, when we're talking about angles of elevation, anything that elevates is going to go up, okay? Um, and so this angle here, so if we can kind of see this as our right angle triangle, being this is your angle of elevation. Okay, because it's from your perspective going from the bottom looking up. Now, if I were to draw a dotted line here as a horizontal, your friend's perspective looking down towards you is a different perspective. Okay, so that angle there is your angle of depression. Okay, so really important that you understand which perspective it is. But what you'll need to note is that based on geometry that we did before, um, hopefully you remember parallel lines, that this angle is alternate to that angle, and they are equal. Okay, they are the same, but the catch I don't want you to make, the mistake that I don't want you to make is this. I don't want you to make that as the angle of depression, because it is not. Okay, it is not the angle of depression. I'll put a big red X on it. That is a mistake that people often make. Please think of the letter Z, and the angle is going to be going from the horizontal going down to the diagonal. Okay, so that's just to get your reference and orientation on what the angle of elevation is, what the angle of depression is, and I've got a couple examples that I'd like to run by to help you solve problem-solving questions and understand how to draw certain diagrams. So let's start off with this one here. So what we have here is it's a common scenario. You've got a ladder, 3.8 meters, that is leaning against a brick wall. Okay, and we know that it is going up at 2.1 meters high. We know the ladder is 3.8 meters long. We don't know what the angle of elevation is. So this is angle of elevation as a reference. Okay, so we need to work out what theta is. The ladder is your hypotenuse, and your wall, or the height of the ladder to the wall, is your opposite, because that side is opposite to theta. So if you look back onto your functions, you'll realize that we need sine, because sine needs the opposite and the hypotenuse. Because we're working at the angle, we need the inverse. Okay, so just what we did recently, we need the inverse, and it's the opposite over the hypotenuse. So the opposite is 2.1 divided by 3.8. And the last thing, all you need to do now is put that in your calculator and let it do the rest. Okay, so here we have the inverse of sine, and then we've got 2.1 divided by 3.8, close brackets, and hit enter. we've got 33.5. Let's round that up to 34. So 34 degrees is the incline or the angle of elevation of the ladder to the wall. Now, the question is, how far is the foot of the ladder from the wall? And that's this part here. We were to change color, I'll change it to green. So what is this distance here? Yep. Okay. So let's call this y. There's a few things. We've got lots of information. We've got that side and that side. We can, because of those two sides, we can work out what that side is. Because we got that side and that angle, we can work out that side. Because we got that side and that angle, we've got quite a few options. So I'll write down the few options that we have. You could say that y squared plus 2.1 squared is equal to 3.8 squared. So you could use Pythagoras. Okay, you could do that and then solve for y. The other option is we could utilize the angle and the opposite. So the angle and the opposite, knowing that this is our adjacent. So if we're using the opposite and the adjacent, we need tan. Okay, so first option is that one. Second option is tan of the opposite, which is 2.1 divided by y. Oh, sorry, whoops. Tan of, what was the angle that we had? 34. Tan of 34 is equal to the opposite, which is 2.1 divided by y, which is the adjacent. And then remember the shortcut was to swap these things around. So y is equal to 2.1 divided by tan of 34. So there's that option there. Third option is we could use the hypotenuse and the angle. So if we've got the hypotenuse and the adjacent, we need cosine. Cosine of 34 is equal to the adjacent, which is y, over 3.8. Okay, and so y is going to be equal to cosine of 34 times 3.8. Now, all three of those options is going to get you the same answer. Because you have more than two pieces of information, it gives you some options and flexibility. Gives you a preference, gives you a choice, which is a great thing. So I'm going to go with the third one, and I'm going to say cosine of 34, close brackets, multiplied by 3.8 gives me 3.15. Okay, so y is equal to 3.15. Make sure your unit of measurements is correct, meters, and because your diagonal is always going to be the longest length, it makes sense that 3.15 is less than 3.8. Okay, so there's the first question. First scenario gives you a few options to choose from. Either of those three doesn't really matter. It's your preference. And I want to finish off with this one. We've got two buildings next to each other. One is 100 meters tall, the other one is 75 meters tall. And we've got the point from each tower at a 20-degree either incline or decline. So remember that this is your angle of elevation and this is your angle of depression. Show that the horizontal distance between the north side of the taller tower and the south side of the smaller building is close to 69 meters. So we're asked to find that this distance, it's already given us the answer, is about 69 meters apart. Okay, So let's kind of work on this and work out how we're going to figure that out. If this is 75 and this is 100, then this distance here should be the difference between the two. So 100 minus 75 is going to be 25 meters. So that's 25 there. So what I could do is I can actually draw the triangle a little bit bigger. This one is 20 degrees. Remember, the angle of elevation and depression is the same because they are alternate angles. This side we've established is 25, and we need to work out what this side is, proving that it is approximately 69. Okay, x is your adjacent, and 25 is your opposite. And here we have theta. So out of the three functions, SOHCAHTOA, we are working with O and A, so we need tan function. So we will write down tan of theta is equal to the opposite of the adjacent. If you don't need to do that anymore, you can just go straight into filling in the details. So tan of 20 is 25 over x. Our unknown is at the bottom of the fraction. So remember, our shortcut is to swap things around. So x is 25 divided by tan of 20. So getting our calculator out, we'll go 25 divided by, and getting our function tan of 20, close brackets, is going to give us 68.68. Okay, so x is equal to 68.68, and if we rounded it off, we round it off to the nearest meter, 69 meters. Great. So hopefully that helps you guys. If you have any questions, let me know. Otherwise, see you in the next one.